Hello, this is Mrs. Ross, and this is Investigation 7. We're going to go through all of it. It's probably going to be fairly long. It may even be two parts, but here we go. So this investigation will show a formal algebraic method for solving equations. This method is called balanced equations. Because the two sides of an equation balance each other, the picture below of the scale below shows both sides of the equation are equal and balanced. So we have x plus 12 equals 33. And then you've seen me do this as long as we've been in class. Whatever you do to one side of the equation, whatever you do to one side of the equal sign, you have to do to the other side so we can keep this balanced. Okay? It says there are two steps to balancing an equation. Select the operation that will isolate the variable. So our goal is to have x on one side of the equals, period. And then you perform that operation on both sides. So this makes more sense when we actually do it. For example, with the x plus 12 equals 33, it says select the operation. So to get the x by itself, I have to take away the 12. So I'm going to subtract the 12 here. I also have to subtract the 12 over here because what I do to one side, I have to do to the other side. When I perform that operation, 12 minus 12 is nothing. My x comes down. We still have our equals, and then 33 minus 12 is 21, and that's here. Okay. They're kind of trying to graphically show you how to solve for these. La, 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 and then they checked it. So what they did to check it was they took the 21, which is what we got for x equals 21, and they plugged it into the x, and it checks out 33 on both sides. So the equation is 45 is equal to x plus 18. This time the unknown number of variables on the right side. What operation will you use to isolate the variables? So right now we're adding. We need to do the opposite of addition. And you're going to write that right here. The opposite of addition. What will you do to keep the scale balanced? So this S comes from this word right here. It's an S word. It's a operation, a mathematical operation from B, both sides of the equation, okay? Tell what will remain on the left side and on the right side once this is performed. So once you do what you need to do, which is subtract 18 and subtract 18, on the left side will be, so left is going to be 45 minus 18, and you can figure that out. On the right side will be x, just like we want it. Okay, and then here's the line-by-line solution. It shows they subtracted 18 from both sides. They get x equals 27, and then they plugged that back in to double check and make sure that it works. Number 4 says, if you reverse the two trays of the scale so that the x plus 18 were on the left and 45 were on the right, would the scale still be balanced? Absolutely. So the new equation is right here. You'll write that right there. Now, look at an equation that has multiplication rather than addition. So we have 2 times x is equal to 132. So the first thing we select the operation, it has to be the opposite of multiplication, which is division. So we're going to divide both sides by 2, and we get x equals 66. This shows what happens. So they divided both sides by 2. They got 66, and then they plugged it back in. 2 times 66 is 132. Oh, where am I going? All right, so use this to show the equation 3x is equal to 132. What operation will you use to isolate the variable? You're going to divide by 3 because we want x by itself. That's what isolating the variable is, x equals. Describe the operations to be performed that will keep the scale balanced. So we're going to divide both sides of the equation by 3, which is right there. And if we do that, once we do that, divide this by 3, divide this by 3, these 3's are going to cancel. We're going to get x equals whatever this is. So you're going to have to do that on your calculator, 132 divided by 3. And then this is the line by line. So this is 132, and this is 132 divided by 3, and then this is your answer. Okay? Once you have that, you're going to plug this in here to see if it still is valid. Okay? Most students would solve the equation by dividing both sides. There's another way. It says you can, the coefficient of x is 3. You can multiply by the reciprocal. That's what they're trying to get us to do. That's a lot of work. But we are going to have to do it when we have actual fractions. So select the operation that will result in 3/4 becoming 1. So we know that 3/4 times 4/3, which is the reciprocal, will give us 12 over 12, which is 1. So I have to multiply by 4/3, right? What operation will you perform to keep the equation balanced? We're going to have to multiply both sides by 4/3. So if we multiply this side by 4 over 3, we have to multiply this side by 4 over 3. 3, that's a 3. Okay, write a line-by-line solution for this. The answer will be an improper fraction, and it says that we're okay with that. Okay, so here we have 9/10 times 4/3. This is going to cancel. We get x. 9 times 3 is 36. 10 times 3 is 30. It says in algebra we usually leave answers that are improper as is unless it asks for a mixed number. Okay, well we can just chill with the 36 over 30. Here we have 9/10. Here we have 9/10. 9/10 and 9/10. Basically they're showing you that this is actually 9/10 and this all works out. Okay, for each of the following, state the operation, tell what operations you'll perform, write the line by line, and check. So that's a lot, but we only have a few. So here we're going to subtract 2.5. We're going to subtract it from both sides. So this is going to be x plus 2.5 equals 7. 7 minus 2.5, and you can do the rest here. Whatever you get for your answer, you're going to plug in here. And hopefully this is going to be 7 equals 7. Here we're going to subtract 2 from both sides. Subtract sides. So this is y plus 2. We're going to do y plus 2 minus 2, which gives me y, or 1y. And then we have y plus 2. We're going to plug in whatever we get for our answer, which is 1.6. And that's 3.6, so that checks out. Here we're going to divide by 4. Divide both sides by 4. So this is 132. We're going to have to do 132 over 4. And that gives us, I think, 33. And then because we're going to have to plug it in over here, this is 132, 132, 132. Okay. Here we're going to divide by 1.2, divide both sides of the equation by 1.2, 1.32, 1.32 divided by 1.2, that's going to give us 1.1. Then we're going to plug it back in to see if we did the right thing. Does that give us 1.32? Okay, gosh, this is gross. Okay, so we're going to subtract 3/4 from both sides. So this is 5/6. This is 5/6 minus 3/4. It looks like that's going to be 1/12 somehow. 5/6 minus 3/4. You would have to common denominator that. And then they plug it in over here. 5/6. 5/6. Here's with a common denominator. This is not reduced, this is reduced. Multiply by 4/3, which is the reciprocal. Multiply both sides by 4/3. So this is 5/6. And then we have 5/6 times, oh, they didn't fill all the stuff out for us on this one. That's great. 4/3, which is 20 over 18, which is the way I'm going to keep it. And then over here we have 5/6, so we're going to do 3/4 times 20 over 18 to see if it equals 5/6. So you'll do the multiplication and then you'll reduce. So multiply and then reduce. We do not have to do 21 and 22 here, however we are going to do the extension. Write and solve an equation for each problem below. Marcia hiked a total of 12 miles on 2 trails. One trail was twice as long as the other. You'll see that here. How long was each trail? So I know S plus 2S is equal to 12. So that's 3S is equal to 12. So you can find out what S equals and then plug it back in here to find out the shorter and the longer trail. Jake earned $50. He put half of his money in the bank. He spent half of the money he did not put in the bank. How much did he have left? So has that much left. He spent, let's see, he put $25 in the bank. And he said he put half of the money in the bank, which is 25. He spent half of the money he did not put in the bank, which is 12.50. So you're going to have to put 12.50 and 25 here, and then you're going to have to subtract to get your answer for what he has left. Mr. Wang's business expenses were $14,250 each month. Company salaries average this. The rent for the company is this. How much should he budget for salaries and rent throughout the year? So we're going to put $14,250 and $26,395 and $28,25. You're going to add all of these and then multiply by 12 to get his annual total budget. And then the last one here, it says, look at the 4 equations below. Which one does not belong? So what you're going to have to do is you're going to have to solve for x, and you're going to find out that 3 of the equations, x is the same. 1, it is not. Let me know if you have any questions.